All right, let's talk about figuring out how many protons, neutrons, and electrons are in a given ion. First of all, pardon my formatting. I promised it was nice on my laptop before I presented on the BenQ board. But let's talk about our calcium 2+ ion. First of all, we know this is a cation because it is positively charged. But when we're figuring out how many protons, neutrons, and electrons an ion or an atom has, it's always best to start at our proton, because remember, our atomic number is also however many protons we have. So we have 20 protons here in this calcium 2+ ion. Next, I'm going to work on my neutrons. Remember that this mass number is going to be protons plus neutrons. So if I want to find neutrons by themselves, I'm going to take my total mass and I'm going to subtract out my proton. 40 minus 20 gives me 20 neutrons. Then the last one are my electrons. The way I think about electrons and protons is like being on a seesaw at a park. If I didn't have an ion, if this was perfectly neutral, then I would have 20 electrons to balance out my 20 positive charges. But notice that we have an excess of positive charge. That means I should have more protons than electrons. How many more? I should have 2 more. So that means I should have 2 fewer electrons than I have protons. 20 minus 2 is 18. So I should have 18 electrons here. Remember that when we are figuring out our charge, we can only change our electrons. We can't change our protons because if we change our protons, we change the identity of our element. So now let's try our chlorine. We're going to start with our protons as always. That's going to be our atomic number. So we know we have 17 protons. Then we're going to figure out our neutrons. 36 minus 17 is 19 neutrons. Now we're going to look at our charge. We know, of course, that this is an anion because it has a negative charge. If this were neutral, we would have 17 electrons. But we know we have an excess of negative charge, so we should have more electrons than protons. How many more? If there is no number, the 1 is implied. This means we have 1 more negative charge than positive charge. 17 plus 1 is going to give me 18 electrons. Now let's try the other direction. Let's say I'm given my protons, neutrons, and electrons, and I need to write the atomic symbol. Again, we're going to start with our protons because they tell us identity. That number lives in the bottom left corner of my symbol. If I go to my periodic table, number 16 has the symbol S for sulfur. Next thing I'm going to do, I'm going to figure out my mass. My mass is my protons plus my neutrons. 16 plus 16 gives me 32. Now I'm going to figure out my charge. If I look, I have more negative charge than I have positive charge. So my ion is going to be negatively charged. By how much? By 2. So this is a sulfur 2- anion. Now let's try the next one. Again, we start with our protons. We know 29 is going to be our atomic number. If we go to the periodic table, number 29 is going to be Cu for copper. Now I'm going to work on my mass. My protons plus my neutrons, 29 plus 34, is going to give me 63. Now I have to figure out my charge. If I look at my electrons, I have more positive charge than I do negative charge, so this is going to be a plus. This will be a cation. By how much more? I have 1 more positive charge than I have negative charge. Our 1s we don't write out, we leave them implied. The last thing I want you to know with this, when we're calculating our masses, is that the masses on the periodic table might not be so helpful to you. The masses on the periodic table are averages My bad. The masses on the periodic table are averages. What this means is that they've looked at many naturally occurring isotopes or different masses of the same element, and they have averaged all of that together using what we call a weighted average. That's how they get the decimal places on the periodic table. If you're looking at just one atom or one ion, like we are here and here, the periodic table doesn't tell you the mass of this atom or ion. You have to be able to add up your protons and your neutrons to get the mass of this specific ion.